Find the particular solution of the differential equation y over x dy dx is equal to y squared plus 1 over x squared plus 1, given that y is 0 when x equals 1. So separating that would give us y over y squared plus 1 dy is equal to the integral of x over x squared plus 1 dx. Now in this case, for example, looking at the left, we could write that as a half of 2y over y squared plus 1. And then the numerator would be the differential of the denominator. So we know in that situation we have ln y squared plus 1. And if we look at this, it's the same integral, except the variable is x. So we've got ln x squared plus 1. And then we have a constant. Now what I would do in this situation where everything else is a log is write my constant as a log. So I'm going to call it log a. And then I can use a log law to say ln y squared plus 1 is equal to ln x squared plus 1, but put the a in here. And then, because log is a one-to-one function, that means that y squared plus 1 would be equal to a x squared plus 1. Now we can use the boundary conditions, y equals 0 when x equals 1, boundary conditions, initial conditions, they're called various things, but they're the values that enable us to work out a. So if y is 0, this side becomes 1, and if x is 1, this side becomes 2a. So that would give me that a is equal to a half. So y squared plus 1 would be equal to half x squared plus 1, and therefore y squared would be equal to a half of x squared plus 1, take away 1, which you might simplify again and make it into something like y squared is equal to a half, and that would be x squared take away 1 if we simplified that. You can just do a bit of algebra there and see that that works.